All right, page 9. Let's start by correcting this. This is not Unit 11. It once was, but it's been renumbered to Unit 9. So we're working on the probability unit here. So Kendall went shopping, purchased 7 shirts, 3 pairs of pants, and 2 jackets. How many different outfits are possible? So we're dealing with 3 categories of items, so we want to use the fundamental counting principle. So that's just 7 times 3 times 2, or 42 outfits. So because we have multiple categories, we need to multiply each category to get the result. 16 different markers in the bucket. How many ways can Kelly choose 5? So that's dealing with a single set and trying to get a subset out of that larger set. So we either need to do combinations or permutations. This one, the order doesn't matter, because we're just drawing markers out of a bucket, so the order they come up doesn't make any difference. How many ways can she choose 5? So we want to do a combination here. N is 16 and R is 5. So put that into your calculator. You get 4,368 ways. And number 65, again, there's one category we're pulling from that larger group. So we're picking 7 out of 12. That's not right. This has been, hang on a second, this has been rewritten on yours. So this should say 12, right? Okay, so, and this should say 20. All right, sorry for the confusion here. Having checked one more time, this is in fact what you have, 12 and 7. So let's keep going with this. In this case, it says, how many ways can you arrange them? The word arrange is crucial here. So now the order matters. And so now we know to use a permutation. So we're going to start with 12 for n, permutation with 7. So put that in your calculator, you get 3,991,680 ways. Okay, good. Moving on. Number 66, you select an even number, replace the ball, select a multiple of 4. So we only have from 1 to 30 in this lottery. And so the first time you select, it will be out of 30. Half of them will be even, so 15 out of 30 will satisfy the first requirement. We're putting the ball back, so we'll maintain 30, and we're going to multiply because we need both events to happen. So the second draw is out of 30. It's a multiple of 4. So it could be a 4, an 8, a 12, a 16, a 20, a 24, or a 28. Those are the multiples of 4 that come between 1 and 30. So there's 7 of them. All right, and if I multiply those together, I'm just going to do a little quick reducing here. 1 and 2. So it looks like I have 7/60ths. Okay, so we select the 7. Well, that means out of all 30, I have picked the one ball that has the number 7 on it. Only one. I replace it, so I'm back to 30 again, and it's a number greater than 10. So that's 11, 12, 13, so on, all the way up to 30. Well, there's 20 numbers that satisfy that, from 11 to 30. So there's 20 numbers. And so, again, quick reducing would give me 2/3 here. So I have 2/90ths. Oh, but that reduces again. Hang on. Right? Because this 2 can also reduce with 30, and that's 1/45. Okay. You select the 24, do not replace the ball, then select a number less than 15. So again, the 24 is only one of those out of 30. We do not replace the ball. So that means our second fraction is out of 29 because the first ball is out. Select a number less than 15. Well, the 24 wasn't less than 15, so we still have all the numbers from 1 to 15 still in the bucket or in the bag. Right, so that's 15 balls out of 29. So some reducing here. Give me a 1 and a 2. And I have 1 over 58. Okay. Actually, I think, wait a minute. It says a number less than 15, right? Not less than or equal to. So that's actually only going from 1 to 14. So let's fix that from 1 to 14, which means the second fraction's out of whack. This should say 14 out of 29. Okay, so this is going to reduce a little differently then. Hang on, let me just redo all of this. Okay, so it's 1/30th and 14/29ths because there's 14 of the remaining 29 that are less than 15. Okay, so now reducing, I can go by 2. It gives me 7 and 15. So 7 over 435. That's my actual probability here. Okay, so just read it carefully so you don't make that same kind of mistake that I just did. All right, table shows the results of a poll of randomly selected juniors who were asked if they attended the prom. We want a probability that a junior did not attend the prom. So we are assuming that the person is a junior. So I want the probability that they did not attend the prom, given that they are a junior. So I am only interested in the juniors. Right? That's all I care about. So to do this probability, I need to be over the total juniors, which is 84. That's my denominator. And of those 84, 56 said no. If I reduce that fraction, I get 2/3. So the key to that is reading the problem carefully enough to see that I am restricting myself to just the juniors, that a junior did not attend the prom. Now, if I reverse that and say, what's the probability that someone who did not attend the prom was a junior? Well, then I'd have to look across the bottom row to all the people that did not attend the prom. Different problem. All right, number 70, probability they attended the prom given that they are a senior. So given that, that's my clue. So I want probability of yes prom, given that they are a senior. All right, so my denominator this time is just the seniors. Just want these. Okay, so that's 97. Why did that stick? Okay, so that's 97, and 19, that's 116. So I don't care about the juniors on this one, it's only the seniors. And of those juniors, seniors, 97 said yes to the prom. And that's not a reducible fraction, so that's done. Okay, on to page 10. So we are surveying at a high school whether we play a sport and or a musical instrument. And we have this summary, this helpful summary here. 60 students surveyed in total. Draw a Venn diagram to represent the situation. So we have sports and musical instruments. So let's make one circle for sports, and musical instruments will overlap it. And I'm just going to label this with an S for sports and a musical instruments MI. And then both will go in the middle and neither will go on the outside. So 40 students play a sport, but I'm going to start with the ones that do both. 15 of them do both. So we'll put that right into that part. If 40 play a sport, and I've already accounted for 15 of them, then that must mean that 25 only play a sport, because this whole circle has to add up to 40. And likewise, this whole musical instrument circle has to add up to 25, but I've already got 15, so that means that I have 10 that are only musicians. Okay, so what do we have here? We have 40 students here plus 10 more here, so I've accounted for 50 students right now. There are 60 total, so there must be 10 that are out here doing nothing, or at least not doing either of those two things. So there's my Venn diagram. I just want to make sure that's perfectly clear. I started with the both. Then I went to each category and said I need 40 total students for the sports circle. And in this sports circle, at that point, I already had 15, so I had to supplement that with 25 more that were only sports athletes. Then I did the same thing for musical instruments. 25 were musicians. I already had 15, needed another 10. 10 plus 15 plus 25 was 50 that were accounted for in one category or the other, and that left 10 students who were surveyed that did not fit either category. So how many students do in either category? There are 10, just looking outside the circle, outside the diagram. What is the probability that a randomly selected student participates in at least one activity? Well, to get that, I could do 1 minus the ones that don't participate in anything, which would be 50/60ths, or 5/6. Or I could just count up the ones that are inside the diagram and do it that way directly, 50/60ths that way. And the last question, what is the probability that a randomly selected student plays a sport given that they play a musical instrument? So I need to be inside the musical instrument circle for this problem. I can only look in here. Okay, and of that circle, how many play sports? That's basically what it's asking. So it's going to be 15 athletes out of a total of 25 in the musical instrument circle. So 15 out of 25 in the musical instrument circle. And the way I notate this is P of sport given musical instrument. And the given goes on the bottom. Sports within that given category goes on the top. So I don't want all 40 athletes here. I only want the ones that fit the category of a musician. So 3/5. And that'll do it.